Welcome to today's video. This is Pawan. In this tutorial, we are going to dive into the world of AWS ElastiCache, especially focusing on creating Redis cluster using AWS Console. But that's not all. We'll also explore how to leverage the power of Rust programming language to connect to Redis server and perform operations like reading and writing data. If you're looking to enhance your knowledge of AWS ElastiCache and Redis and you're curious about using Rust for this task, you're in the right place. Let's get started. ElastiCache is a managed service offered by AWS that provides Redis and Memcached as in-memory databases for caching, which offers high performance and low latency. Caches serve the purpose of offloading read-intensive workloads from your primary databases, thereby reducing their load. Additionally, ElastiCache allows your application to operate in a stateless manner. Consider a stateless e-commerce application website where user sessions are managed using ElastiCache. When user logs in, their session data such as user shopping cart, selected items, and preferences are stored in Elastic Redis cluster. This data is associated with the session ID. The session ID is included in each user's request as a cookie or a parameter. By using ElastiCache for session management, the web servers don't need to maintain user-specific data. They can retrieve session data from the cache using session ID in each request. This allows the application to scale horizontally by adding or removing web servers as they needed without worrying about sharing or replicating session data between them. It also simplifies load balancing because each request is independent and does not rely on the state of a specific server. This stateless architecture results in more robust and scalable e-commerce platform. AWS works on a shared responsibility model where AWS is going to take care of some things and user will take care of some things. AWS takes care of various aspects of the service, including OS maintenance, patching, performance optimizations, setup, configuration, monitoring, failure recovery, data backups, relieving you from these operational burdens. Users have certain responsibilities such as cache configuration and optimization, cache data management, application integration, access control and authentication, backup and recover strategies. Using ElastiCache involves heavy application code changes. To use ElastiCache effectively, you might need to modify your application code to check the cache for data before querying the database, and to update the cache when the data changes. Next, ElastiCache for database caching architecture. In this architecture, your application first queries ElastiCache for data. If the requested data is not available in the ElastiCache, then it will retrieve it from the Amazon RDS and store it in the ElastiCache for subsequent requests. This approach is effectively reduces the load on your Amazon RDS database. To ensure that the cache data remains up to date, a proper invalidation strategy is essential, ensuring that only most current data is stored in ElastiCache. Now let's take a look at ElastiCache Redis cluster. ElastiCache Redis cluster provides multi-AZ with auto failover. It is a feature that ensures high availability and fault tolerance for your Redis instances. It involves running a primary Redis node in one AZ and a standby node in another. In case of a failure, the system automatically fails over to the standby node. For example, imagine you have a Redis cache running in one AZ and a network issue or hardware failure occurs. Multi-AZ with auto failover ensures that standby node in another availability zone takes over, preventing downtime of your application. Read replicas to scale reads and ensure high availability. Read replicas are copies of your primary Redis node that can handle read requests. They help distribute the read load, improve read performance, and ensure high availability. For example, let's say you have an e-commerce application where a product catalog is stored in Redis database. By creating read replicas, you can direct your read request to these replicas, reducing the load on the primary node and providing faster response time to users. Data durability using AOF persistence. Append-only file persistence is a method for ensuring data durability in Redis. It logs all the write operations and can reconstruct the dataset in an event of system crash. For example, If your Redis instance is configured with AOF persistence, every write operation is logged to an AOF file. In case of server crash or restart, Redis can replay AOF log to restore the data to its latest state, ensuring data integrity. Backup and restore features. Redis provides mechanisms for backing up and restoring your data, which is essential for data protection and recovery. For example, you can use Redis built-in backup and restore tools to create snapshots of your data. These snapshots can be stored in AWS S3 or other storage solutions for safekeeping. In case of data loss or corruption, you can restore your Redis instance from the recent backup to recover the lost data. Elastic Redis cluster has two cluster modes. First one is disabled cluster mode. In this mode, we create a Redis cluster in which there is only one shard which contains all the Redis nodes. One of the nodes is designated as primary node and the others are called read-only replica nodes. Second one is cluster mode enabled. In this mode, we create a Redis cluster in which there are 1 to 90 shards. Each shard has a primary node and up to 5 read replicas. Each read replica in a shard maintains copy of the data from the shard's primary node. Also, Redis supports sets and sorted sets. Now let's go ahead and create ElastiCache Redis cluster. Navigate to ElastiCache service. On the Getting Started page, select Get Started and select Redis. Here we have to choose a cluster creation method. There are three options. Easy create. Uses recommended best practices configuration to create your cluster. You can also modify options after you create this cluster. Next we have configure and create a new cluster. Here we have to set all the configuration options for our new cluster. Next we have restore from backup. You can use an existing backup or .rtb file to restore a cluster. Select configure and create a new cluster. Next you have to choose a cluster mode. We have two, enabled and disabled. Enabled cluster mode enables replication across multiple shards for enhanced scalability and availability. Next we have disabled. The Redis cluster will have single shard with one primary node and up to 5 read replicas. Here we'll select disabled. Now we have to give our cluster a name. We'll call this Redis cluster. Next we have to choose whether to host our cluster in AWS cloud or on premises. Here we'll choose AWS cloud. You can also host your Redis cluster on premises using AWS outposts. AWS multi-AG is already enabled along with the auto failover. Now we have to choose cluster settings. Here engine version compatibility of Redis engine that will run on your nodes. We'll leave it as 7.0. Port. The default port that the nodes accept connections on is 6379. Next we have to select parameter groups that control the runtime properties of your nodes and cluster. We'll leave it as default. Next we have to select how much memory and network performance is needed. We'll also leave this as default. Next we have to choose number of read replicas we need between 0 and 5. We'll select 2. Now we have to choose our connectivity settings. Here we have IPv4, IPv6 dual stack. We'll leave it as IPv4. Next we have to create a subnet group. Let's call this Redis subnet group. We'll select the default VPC. Next we have availability zone placements. Here we can specify availability zones, like where you want your primary node to be placed, in which availability zone you want it to be placed. You can choose that here, but we'll leave it as no preference and select next. In security, we can enable encryption at rest and we can enable encryption in transit. We'll leave them as defaults. Next we have to select a security group. Click manage. Now we have to create a security group for our Redis cluster. Now let's go ahead to EC2 security groups and create a new security group. We'll call this Redis security group. Let's give it a description. This allows traffic to Redis cluster from anywhere. Let's create an inbound rule. We'll leave this as custom TCP. Port is 6379, which is the port of our Redis cluster. Next, we'll choose anywhere IPv4 and click create. Let's head back to ElastiCache console and hit refresh. Now you will see your newly created security group. Select Redis security group and select choose. Next, we can configure our backup and maintenance windows. We'll leave them as default and we can enable logs as well. Click next. Review all your settings and hit create. This will create our Redis cluster. Now our Redis cluster is created and available. Now if we scroll down, here we can see the nodes that are present in our cluster. We have one primary node and two read replicas. These are the endpoints to connect to these nodes. Next we have metrics. Here we can see the CPU utilization, data memory usage, cache hit rate, etc. Next we have logs. If we enable logs, the logs will show up here. Next, network and security settings. Here we can see the security group that we configured. Next we have maintenance and backups window. Next we have service updates. If there are any, they'll show up here. Next we have tags. This is the primary endpoint that you can use to connect to this Redis cluster to read and write data to it. Now let's create a REST application to connect to our Redis database and perform actions like reading and writing data. Before doing that, I just want to quickly mention one point. ElastiCache is a service designed to be used internally within the VPC. External access is discouraged due to the latency of internet traffic and security concerns. However, if you want to externally access ElastiCache for testing or development purposes, it can be done through a VPN. Using AWS Client VPN, you can allow external access to your ElastiCache nodes. So here I am using an AWS service called Cloud9, which allows you to write, run, and debug your code with just a browser, which is technically your Cloud IDE. With AWS Cloud9, you have immediate access to a rich code editor, integrated debugger, and built-in terminal with pre-configured AWS CLI. Now let's create a new cargo project using cargo new command. Cargo new Redis client. Feed into the Redis client. Now go to cargo.toml and add Redis as the dependency. Go to main.rs file and import Redis commands, right, which provides methods for interacting with Redis server. Now let's create a Redis client which connects to our Redis cluster primary endpoint. For this, select client Redis client dot open Here you have to pass the connection string. You can get the connection string from the AWS console. If you come into your Redis cluster, here you can see primary endpoint. Copy this URL, paste it here. Dot unwrap. So this code opens a connection to the Redis server. If the connection cannot be established, then unwrap causes panic. Now let's set a key value pair into the Redis server. To do that, we can use client.set method, which takes in a key and a value, passing key as key and value as hello world. We have to call unwrap. So this set method returns a result, that is unwrapped, using unwrap. This result of this function is discarded since we are only interested in this side effect of the setting the key. To retrieve the value associated with the key from the Redis server, we can use client.get method. Let's create a variable called key. So of type string. Use client.get. We have to pass the key, which is key. We have to unwrap. So this get method returns a result which contains the value of the key, which is unwrapped into the key variable of type string because the value is of type string. Now let's print the key to the console using println macro. Save the code and run it using cargo run command. Yeah, we are now successfully able to set a key value pair in the Redis server and get it back from the Redis server. Make sure you delete your AWS resources so that you don't get any unnecessary charges. Go to your ElastiCache Redis cluster and here you can delete the Redis cluster. Select no. Confirm deletion. Delete it. It will take some time to delete. Thanks for watching. In the next video, we'll explore advanced caching patterns like lazy loading and write-through. Subscribe for more insights into optimizing your applications using Rust and AWS. Happy coding!